Good day, everyone. Welcome to Chem Classroom with Auntie Taiwo. So today we'll be discussing about water. Yes, water is a very common compound that we find around us. As we all know that water is what? Water is H2O. So water has how many atoms of hydrogen? 2. Then just 1 atom of oxygen. So most times we refer to water as an oxide of what? Hydrogen. So we'll have some outline today. We're talking about the physical and the chemical properties of water. We're talking about hardness of water. Then we'll also be talking about the treatment or purification of water for town supply. Then we'll go into the test for water and water pollution. So we have a bit of work to do today. Please follow me gently. Okay, now coming to the physical and chemical properties of water. Right from primary school, you know that color is a what? Water is a colorless, odorless, and a tasteless liquid. Any water that is tasteless or that has a taste or has color, then is no longer water. Maybe probably you have other things added to it. Okay, now your water boils at what? 100 degrees Celsius, and it freezes at 0 degree Celsius. Then it has a density of 1 gram per cm. Okay, now it's also neutral to litmus paper. We know that our litmus paper with acid and the base, for the acid it turns the blue litmus paper red, and for the base it turns the red litmus paper blue. So in the case of water, is neutral. It doesn't have any color change. Either you test with the blue litmus paper or the red litmus paper. Now going to the chemical properties of water. Now for the chemical properties of water, your water can react with some metals like your sodium, like your potassium. Now basically when you react your water with your sodium and your potassium, so let me use potassium as a good example. My potassium plus what? H2O. So the hydroxide plus hydrogen gas will be liberated, and the hydroxide will be formed. This is your potassium hydroxide, this is your potassium. So let's try and balance the equation. So I have something 2, I also put 2 here and put 2 here. Okay, now the same reaction also goes for sodium and calcium. Now there are some of these metals also that do not react with water in the liquid state. This is the liquid state. So like your magnesium and your zinc, they react with steam, which is the water vapor. Yes, to also give what? Hydrogen gas will be liberated and oxide will also be produced. Then another one is that your ion reacts with what? The red hot steam. So you have something like this, plus how many moles of water? I have 4 here, then to give me the 3 or 4 plus. Hydrogen gas will also be liberated. So the ion will have to be what? Red hot. Then we have some metals that do not react with water at all, like your silver, your gold, your mercury. They don't react with water in any form. Then we also have reactions with non-metals like our carbon. When carbon reacts with water, water gas is being formed. For some of us that have done something on that carbon in our various schools, so this is what we call the water gas. Yes, this is what we call the water gas. Then you can also have reaction with oxides. When water reacts with oxides, of course hydroxides and all your alkalis will be formed in the process. Okay, right there, let's move to what we call hardness of water. Now you say your water is hard when it doesn't lather well with soap. There are some water that you come in contact with that even when you put your detergent or whatever, it will not form well. That kind of water is what we call hard water, and the process is hardness of water. Now you can have the temporary hardness of water and you can have the permanent hardness of water. Now for the temporary hardness of water, it can be removed by boiling, or by adding your slake lime, calculated amount of slake lime, because if you add excess, the water becomes permanently hard. Yes. Then for the permanent hardness of water, it can be removed through distillation. It can also be removed by the addition of washing soda, by the addition of caustic soda, or the Palmont process. Yes, it depends on the one you choose to use. Okay, now that being said, coming to the treatment of water or the purification of water, we are going to go through a process. And as I'm explaining, I will have to list them on the board. The first thing you do is to what? To collect the water. Collection of water, either from rainfall, stream, lakes, wherever you want to get your water from. Then after that, you aerate the water. You stir the water so that if there are some odor, volatile gases and all that. So the next one is your aeration. Then after the aeration, you have what we call the coagulation. Now for some of us that have stayed in the village for some time, especially during the dry season, maybe you went to fetch water at the stream and the water is muddy, you drop what we call halum, yes, in the water. So we also use that. So you can drop a compound like halum or your aluminate. There's an aluminum compound that you drop for the coagulation to take place. So when you drop it, the solid substances, the solid particles will come together and gather together. Okay, that is your coagulation. Then after the coagulation, then the water is being passed through what we call the filter bed. For some of us that have seen filter paper in the lab, but because we are doing what? A large body of water, it will be passed through the filter bed. So this process is what? Filtration. Then after the filtration, the fine particles have been passed through. Then you have what we call the chlorination. Now, addition of chlorine kills the germs. Maybe there are some bacteria in the water. It kills the germs so that it should be safe for drinking. Now, the last step is what we call the pH control. The pH control, we need to test the pH of our water. If the pH is actually safe, because according to World Health Organization, safe drinking water, the pH should be between 6.5 and I think 8.5. So we all know that our pH is between what? 0 to 14. So the middle here is neutral. So, and by the time you go backwards, your acidity is increasing. Then if you go up, the alkalinity is increasing. So your water should not be more than what? 6.5 to 8.5. So if the water is too acidic, an alkaline substance can be added. If it's too basic, an acidic substance can be added to at least balance up for the pH. And after this, your water is being stored in tanks and is being channeled through pipe to our various homes. Okay, now the next thing we'll be talking about is test for water. How do you test for water? When water is being added to our CuSO4 and anhydrous CuSO4, a blue PPT is being formed. So when a blue PPT is being formed, that is to show that water is present. Then the last one that we'll be talking about is what is water pollution. Now, water pollution is introduction of toxic substances, harmful substances into our water bodies. Yes, and this makes it unfit, unsafe for human consumption, even animal consumption, or even plants. Okay, now your water pollutants, we have some water pollutants, we have the refuse and the sewage, we have agricultural and industrial waste, and another one that we have is the oil spillage. Yes, pollution of water bodies, and this affects a whole lot of things. So in the comment section, I want you to tell me some things that we are expected to do to prevent water pollution. So today we have been able to talk about water. We started from the physical and the chemical properties of water. Then we moved to the hardness of water. Then we also discussed about what? The purification and or the treatment of water for town supply. Then we went to test for water and water pollution. So please share, like, and tell your friends. If you have not subscribed, you are very, very wrong. Tell your friends that Aunty Taiwo is teaching on Chem Classroom. Thank you for staying tuned. God bless you.